Hey guys, Hoffbauer here. We're starting what in the book would be chapter 5. We're moving on with some new trig concepts that are in a little more theoretical and really important for calculus. The first one is simplifying with trig identities, and the idea here is that to simplify a trig expression means to rewrite it as a numerical expression or in terms of a single trig function or number. The numerical expression means it might all simplify down to 1 or 2 or something like that. Identities are useful in simplifying trig expressions. So we are going to visit our friendly trig exchange bank. It's kind of like when you go to the bank and you turn in some 2 10s to get a 20, okay? So these are the things we can trade in. When we see a 1 over cosecant, we can trade it for a sine. When we see a secant, we can trade it for a 1 over cosine. All of these inverse identities, reciprocal identities, I need to say those carefully. These are reciprocal identities and you should memorize these, okay? Quotient identities I talked about when we were doing unit circle stuff a lot. Tangent is sine over cosine, and cotangent is cosine over sine. Part of your work this week is to fill in a flip chart where you just have to drag and drop all these identities into the right spots. So this page right here will help you, as will the reference sheet. All right, really super important. The sine squared of an angle actually means the sine of an angle squared. We should really write it like this, but everybody got tired of writing parentheses, and this is not what it means, okay? Because it's not the angle that's squared, it's the whole function. So rather than have to write with the parentheses, some genius decided we'll just put the squared on the function, okay? But you have to be really careful that it is the whole function that's squared, and you need to understand that. It's not the angle that's squared. So when we see cosine squared, it really means cosine of the angle times cosine of the angle. All right? We've talked about x squared plus y squared equals 1 on the unit circle. And we talked about that cosine and sine are the x and y values on the unit circle. So by Pythagorean theorem, sine squared plus cosine squared equals 1. Okay? This is called the Pythagorean identity, and it's a huge foundational concept for everything from here on out. There are 2 additional Pythagorean identities, we call them, and I just want to show you real quick. I honestly don't have those memorized. I have to really think about those. But what you do to get those, if you just memorize this one, what you do to get the next one is you divide everything by cosine squared. And those are all supposed to have thetas. I'm being lazy. But a sine over cosine is a tangent. So a sine squared over cosine squared is a tangent squared. Cosine squared over cosine squared would be 1. And the reciprocal of cosine is secant. So by dividing this first one all by cosine squared, you get this one. Then the other one is if you chose this first one and you divide them all by sine squared, sine squared over sine squared would be 1. Cosine squared over sine squared would be cotangent. And 1 over sine squared is cosecant. Okay? So that's where those come from. And if you don't want to memorize all of them, if you can just remember the first one, that would help you come up with the other 2. I do know that in years past, if you happen to choose a U of I school, their placement test had some trig identity work on it. You don't get a reference sheet. The other thing you need to know is that these can all be rearranged. So sine squared plus cosine squared equals 1. We could subtract the cosine squared over to the other side, or we could subtract the sine squared over to the other side, or we could even do like a sine squared and subtract the 1 over here and subtract the cosine squared over to the other side, and it would be negative. Okay, so these can use algebraic concepts to rearrange these. The other thing that you can do is that you can factor them, because these are difference of squares when you write them, say, in this form. You can factor this side as secant minus 1 times secant plus 1. All right, and you're always supposed to write the angle theta in there, or angle A or B or whatever it is. But if you forget, don't worry about it. I'm not going to count it wrong. Just be careful on when you're using delta math. All right. All right, guys, I had to stop this recording because the bears were playing. So now I'm starting up again. I hope I can piece it together and make it work. But these are the different strategies you can use to simplify trig expressions. It says rewrite using reciprocal and quotient identities. So basically, like, change everything to sine and cosine. And look for Pythagorean identities or possible way to create one. That's a biggie. If you see any squareds on anything, okay, watch for those. Combine fractions using a common denominator. Important right there. Break fractions apart. Now there's two ways that can happen. If you have something like 2 over x plus 4 divided by 2, you can divide this out and cancel it. Or if you have x plus 4 over 2, you can split it up. Because this is a common denominator, we can just say it was really this before we added it together, and then we could reduce, okay? And then use factoring whenever you have a squared or quantity. Look for factors. All right, this is from another year. I had this slide. I said, start by rewriting in sines and cosines. Look for identities to trade or simplify. You may need to factor, may need a common denominator. Use conjugate if fraction is not wanted. Try something different. If you get stuck, start over and try it a different way. All right, so I'm going to just walk you through some of these. I would start by changing this secant is 1 over cosine, reciprocal relationship, minus sine. Okay, leave that one, and it's on the top if you're writing it as a fraction. And then times tangent. Well, tangent is sine over cosine. So if we combine these two, we have 1 minus sine squared. And this one was over cosine, and this one is over cosine. So if we combine it into a single fraction, they have a common denominator. Okay, I can write it separate first if that. But then we can combine them. And remember this guy? Sine squared plus cosine squared equals 1. So if we were to subtract this over here, you would have cosine squared equals 1 minus sine squared. Just reminding you. So therefore we can trade that out for a cosine squared. And one of these will divide out one of these, and we just get a cosine. Okay, so that mess we started with simplified down to a cosine. Again, I'm going to go with sines and cosines. So I have the sine of A plus the cosine of A times sine A over cosine A. This tangent is sine over cosine. Now here, these divide out, so I end up with sine A plus sine A, And just like anything, x plus x is 2x, so this is 2 sine A. That's a nice one. All right, number 3, I see these squareds. Now, when I originally did this problem, I changed everything to sines and cosines, and I eventually got an answer. But then I realized, wait a minute, there were squareds, and that's a form of this guy right here. So very carefully, if you rearrange this, cotangent squared minus cosecant squared, you subtract that over to this side. You could subtract the 1 over to the other side. Maybe I'll show that in a couple steps here. Okay, so if we thought of this as cotangent squared equals cosecant squared minus 1, and then you subtracted the cosecant squared, you'd get cotangent squared minus cosecant squared equals -1. So that's what this turned out to be. I'm going to super fast show you what I did. I did cosine squared over sine squared minus 1 over sine squared. They had a common denominator, so I said cosine squared minus 1 over sine squared. And then I said, wait a minute, this guy, cosine squared minus 1 would be a negative sine squared. And then these divided out and I got -1. But this is fine. Either way you do it, comes out -1. I'm just trying to show you that there's not always one way to get there. This one I also could do 2 ways. I might not, just to save time on the video. Honestly, the easiest way is if you recognize this right here, sine over cosine is a tangent. And remember, you can separate this because it's multiply. So we have this still. So this would trade for a tangent. Tangent times tangent is tangent squared. But cotangent is the reciprocal of tangent. So this is like tangent times 1 over tangent, which is going to be 1. So then we have tangent squared plus 1, which right here, tangent squared plus 1 is a secant squared. Notice I lost my x's different places. Don't worry about it. Okay? I'm not going to do that one another way. It's just time consuming. You could change everything to sines and cosines, and I promise it would work out in the end. You'd end up with a 1 over cosine squared, which is a secant squared. I can go back and put it in the notes if you want me to. 1 over sine minus cotangent squared. Anything I could do with that here? Cotangent squared. Well, it could be a cosecant squared minus 1. Yeah, I think not. Alright, so it is a cosine squared. Cotangent is cosine over sine, but it's squared. And then it is being divided by a cosecant, which is a 1 over sine. So, if I leave this one and flip this over, because that's what you do when you divide fractions, right? This will cancel one of these signs down here so that we only have a sign. And then we have a common denominator. So now we have 1 minus cosine squared all over a sine. Well, remember, cosine squared plus sine squared equals 1. So therefore, 1 minus a cosine squared would be a sine squared. So I'm going to try that out for a sine squared over a sine, which would be like sine times sine over sine. We're just going to, one of these is going to cancel one of these out, and we end up with sine of theta. That was really messy, sorry. All right, I'm going to separate this because I talked about this. When you have a denominator and adding or subtracting up here, this is a common denominator. So you could write cosecant of beta over cosecant of beta. And anytime you don't like this letter, you can trade it out for a theta or an x. I will never judge. All right, cosecant divided by cosecant is 1. This is sine divided by cosecant is 1 over sine, which is sine times, and you flip that over and you get sine over 1. So we end up with 1 minus sine squared. And if you go back here, 1 minus the sine squared would be a cosine squared. You got to learn these identities. All right. This one's interesting. So secant is 1 over cosine, and it is being divided by a sine. And then we have minus a sine over a cosine. If we rewrite this, this is 1 over cosine times 1 over sine. Divided means multiply by the reciprocal. Minus sine over cosine. If we multiply these together, we get a 1 over cosine sine. Nothing nice. Minus sine over cosine. Now this actually shows up a lot where you have to get a common denominator. So the common denominator is going to have a cosine sine. But over here, we need there to be a cosine sine down here. In order to do that, we have to multiply top and bottom by sine. So we end up with a sine squared over a cosine sine, which is 1 minus sine squared all over a cosine times a sine. Well, 1 minus sine squared is a cosine squared. So one of these cosines is going to divide out. And we end up with cosine over sine, which, sorry, I did this really messy, which is a cotangent. So we got it down to a single function. All right, a few more here. Tangent. Can't separate when you have two things in the denominator. Oh, I remember this one, I think. We're going to use a calculus trick here. We're going to write tangent as sine alpha over cosine alpha. And secant is 1 over cosine minus cosine. Okay. The trick in calc that they use a lot is when you have a complex fraction, you have fractions within fractions, you figure out what the common denominator would be, and the only denominator in this problem is cosine. So you multiply the whole top by cosine, and you basically cosine over 1, and you multiply the whole bottom by cosine as well, or cosine over 1, because that's just a form of 1, okay? And then you're going to get rid of your denominators and you end up with a single fraction. So up here when I multiply, those will divide out and I just wind up with sine. In the denominator I'm distributing, so cosine times 1 over cosine will just be 1, and cosine times cosine right here will be cosine squared. And then this is an identity. 1 minus cosine squared is sine squared. And then one of these sines will divide out one of the squared, and we get 1 over sine. and 1 over sine is cosecant. All right. This, the last two I have here, I think it's the last two, are factoring or unfactoring. In this case, we're going to FOIL the top together, so we get a cosecant squared minus a cosecant plus 1 cosecant minus 1. These add to 0. So I have a cosecant squared of x minus 1 all over cosecant squared of x. Now, couple options. This is a trade, cosecant squared of x minus 1. Cosecant squared minus 1 would be a cotangent squared. If we rearrange that guy. But I also see that we have a cosecant squared over a cosecant squared minus a 1 over a cosecant squared. I don't know if this is a good idea or not, but cosecant, I've just separated it because we had a single denominator. And this is 1. Now, this is 1 divided by 1 over sine squared. Well, when you divide, you multiply by the reciprocal, so this becomes 1 minus sine squared. It's also, I think, in your notes that the reciprocal of cosecant would be sine. Here, a 1 over cosecant is a sine right there. All right. Where was I? And at the end here, a 1 minus sine squared is a cosine squared. All right. Tangent. This is looking like we're going to need a common denominator. So tangent is sine over cosine. Cosine over 1 plus sine. This is messy. All right. I should probably have skipped this one. We're going to need a common denominator, so we're going to multiply this guy by a 1 plus sine over a 1 plus sine. And we're going to multiply this guy over here by a cosine over cosine to get a common denominator. And distributing up here gives me a sine theta plus a sine squared of theta. Remember, we now have a common denominator that has both a cosine and a 1 plus sine. Over here, we'll multiply these two together and we get a plus cosine squared. Now, this is kind of tricky, but we can add these two because what is a sine squared plus a cosine squared? It is just 1. And then this quantity, sine plus 1 and 1 plus sine, is the same quantity, so we can divide that out. We end up with a 1 over cosine, which is a secant. Yep, I probably won't put that on a quiz. All right, this is a factoring question. I wanted to do one of these. We can factor out a tangent squared, and then we'll have a 1 minus sine squared. Everybody see that? That's really important. You're going to do a lot of factoring when we get to equation solving. Take out a tangent squared. It's a 1 minus sine squared. Now, tangent squared is sine squared over cosine squared. 1 minus sine squared is a cosine squared. These will divide out. We're left with a sine squared. And last one. This also can be factored on the top. We can take out a sine cubed. When we take that out here, we'll have a cosecant cubed minus 1. So that when we multiplied it back together, we'd get what they have here. Now, I don't know, there might have, this was a squared, not a cubed, sorry. Might have been a better way to do that, because sine and cosecant are reciprocals, so we could have canceled some of them. I'm going to keep going with what I started here. Cosecant squared minus 1. Let's see, where are my Pythagorean ones? Cosecant squared minus 1 is a cotangent squared. So I have sine cubed times cotangent squared, and it's all over, and I can put this under just 1 if I want, because it's multiplied on the top. This is the same thing, right? Because it's all over, same thing. Okay, so this would be a tangent cubed. Cotangent is the reciprocal. It's 1 over tangent, but it's only squared. So this would divide out 2 of those, and you'd have a tangent. Okay. I just wanted to show you the factoring part. I'm not going to ask you one that complicated. All right, so I think this video is about 26 minutes. You are to try a few on the practice.